Hey everybody, is Mr. Dunzo with you. So let's go ahead and get started. We're going to continue with problem number 3 from your test. So make sure you're working hard on those corrections. Make sure you think about what mistakes you made. Make sure you fix them. And then if you don't understand or there's something you're not quite sure about, let us know, and that's what we're here for, to help you out and make sure we fill all those gaps or anything that's missing. Okay, so here we go. Example 3 says, find the exact value of all of these problems, right? Some of them are a little bit simpler than others, but, well, let's see. Here we go. Problem number 1, or problem number 3, part 1 says, log base 2 of the cube root of 64. And we want to go ahead and simplify and find the answer for this. Now, remember, this is just a fancy, crazy way to write a simple number. So let's see what that number is. Let's find out. First of all, remember that when we're dealing with logs in logarithmic form and we want to simplify, we always simplify our radicals. We turn them into an exponent. So let's go ahead and do that. This is the cube root. So the cube root is the same as raising 64 to the 1/3 power. So let's go ahead and rewrite it. So this is the same as log base 2 of 64, but the cube root is the same as the power of 1/3. Now, if you're thinking, well, how does he know that? How does he remember that? Well, remember that if the square root of 64 is 64 to the 1/2, well, square root square means the 2. So technically there's a little 2 there. We never write it, but that's what goes on. So if you have a 1/3, then that means this must be a 3. Okay? So that's basically where that comes from. Okay, so here we go. Now, so let's go ahead and simplify this now. Now 64 to the log base 2 of 64 to the 1/3 power. Now there's different ways you can go from here. Okay, one of the ways is you can go ahead and throw the 3 in the front and then find out what log base 2 of 64 is. That's one way. So doesn't really matter how you do it. So let's go about it that way. So I'm going to take the 1/3 since this is my power property. Remember those? We can put the exponent in the front. This is one way to do it. There's more than one way, like I said. So now, all you're asking yourself is this. 2 to what power is going to be 64? Think of basically an exponential form means 2 to what power is 64? Well, let's see. 2 to what power is 64? Well, let's see. 2 times 2 is 4. 2 times 4 is 8. So basically, what it's going to come out to is going to be to the 6th power. So it's going to be 1/3 times, this is 2 to what power is 64? Well, the answer is 6. 2 to the 6th power is 64. So we end up with 1/3 times 6, which is 6 over 3, which is 2. That's one way to do that problem. Like I said, there's more than one way, but there's that way right there. Okay. Now, problem number 2. Natural log base e of e to the 2/7 power. Well, this one is really nice, really easy, because you know that natural log has a base e, and when your base is the same as this number here, then you know that those two, it's kind of like they cancel or they go away. It's your inverse property. So basically you end up with just your exponent, which is 2 to the 7th, because of the inverse property. Now, if you don't understand why that happens, it's because, think about it. This means this, right? This means e to what power equals that right there, right? Well, in order for those two to be equal, what does x have to be? Well, there you go, 2 over 7. Okay? But you don't have to do that, because you know that if the base and this number are the same, you just eliminate them, and there's your answer. Let's go over here, and notice this problem is the exact same thing as this. You're thinking, well, wait a minute, this is a natural log, that's a log. Yeah, but what I'm talking about is about your inverse property. It's the same thing. There's your base, there's your number, so look what happens. Oh, and we end up with just the exponent. Once again, if you don't understand why that happens, look, this means 9 to what power equals that number, right? Well, what does the exponent have to be so they're exactly the same? Well, 9. See? It's the same thing. Okay? Now let's go over here. This problem over here, like I said, once again, we have a radical again, so we're going to turn this radical or a root into an exponent. So let's go ahead and do that. So this gives me log base 5. Now this is an 8, which means the 8th root, which means the exponent should be 1 over 8 of 25 to the 1 over 8 power. This 1/8 power is the same as saying the square root of 8. Okay? Now, there's different ways to do this problem. We can go ahead and do the exact same method we did here, which is let's use the power property and put the 1/8 in the front, and then we can find what log base 5 of 25 is. You could do that, or you could also convert this into base 5. So we could do this. I'm going to take a different approach. So you see that you got options here. You're not stuck to just one way. There's different ways to do it. I'm going to do it a little bit different on this time, just so that you can see. This is log base 5 of, now 25 we know is the same as 5 times 5, right? 5 times 5 is 25. So I'm going to say that 25 is the same as 5 to the 2nd power. Notice, log base 5, those are the same. 25 is the same as 5 squared, correct? Yeah, it's the same thing, right? Well, but notice that there's also a 1/8 over there, so you can't ignore that guy, so you got to write him in. Well, so what do we end up with? We end up with log base 5 of 5 to the 2 times 1/8 is 2 over 8, which is 1/4, right? So, but look what happens here. This is the same base. That's the same number. Remember what happened in the previous problem, like this one? Remember what happened on this one? This is the same thing. Look, so what is going to be my answer? My answer is my exponent, which is 2 over 8, which is 1/4. And so there's that one. Okay, now let's go over here. Over here now, this is another logarithmic problem. This is log base 4 of 1 over 64. Okay, so let's see. Now, notice that my base is 4. Since my base is 4, I notice this number is 64. So in my mind, I'm thinking, well, wait a minute. Can I write 64 as base 4? And I'm thinking, 4 to what power is 64? 4 to what power is 64? So I use my calculator just to double check. But actually 4 to the 3rd power is 64. I'm not going to lie. You guys know me. So this is the same as this. Log base 4 of 1 over 64. Well, 64 is the same as saying 4 to the 3rd power. Okay? This and this are the exact same statement. Look, 1 over 4 to the 3rd. Well, if you find out what 4 to the 3rd is, it's 64. Okay? So this and this are the exact same thing. Now, let's go ahead and simplify a little bit more. Log base 4 of... Now, remember, we talked about this. We used this many times. When we take this number from the denominator and we move it as just as a regular base, right? Remember your exponent, you change the sign, it becomes a negative. So this is the same as 4 to the negative 3 power. And you're thinking, well, why did I do that? Because look, 4, that is 4 right there. Remember what happened? 5, that was 5, and those go away. Same thing over here, remember? E and E, 9, 9. So look, why did I do that? Because look, now I can get rid of those guys, and my answer is just simply negative 3. We're done with that one. And last one over here, log base 7 of 1 over 2,401. Now, this problem and this problem are basically the same type of problem, because 24 or 2,401 is just basically 7 to the 4th power. Now you're thinking, well, Mr. Junza, how will you know that that's 7 to the 4th power? I mean, well, one of the things is, if my base is 7, in my mind I'm thinking, okay, what would be the easiest way to solve this problem? And I'm thinking, well, if this were somehow exponents of 7, then I can get my bases to go away. So all I did is like, well, let me check if this is really, I can write this as 7 times 7 times 7 several times so that these numbers could go away. So let's see. So we end up getting log base 7 of 1 over, this is actually 7 to the 4th power. And you can check in your calculator. 7 to the 4th power is going to give you 2,401. Now, once again, this problem and this problem, look at them. It's the same thing. So all we're going to do now is we're going to take our 7 to the 4th power and just turn it into a normal base. So we get log base 7 of 7 to the, since we're moving into the top, is going to be a negative 4. And now look, 1 to 1. Same number, same number. So those go away, and my answer is negative 4. And we're done.